Okay, dudes, let's get some game dev going. Okay, we are on texture manipulation. To do graphics effects often requires pixel access. In this tutorial, we'll be altering an image's pixels to white out the background. Okay. So we are going to add some function load from pixel. So let me go and open that up. And here you go, game development basic tutorials. Let's copy this, name it 40 and texture manipulation. Texture manipulation. I hope I'm right. Texture manipulation, yes. Okay, so I want to go here and let's delete this. Let's delete this. And okay, we'll start by altering the header file. So I will just open that. Can I create a new alias? Let me see. Creating aliases in PowerShell. Okay. PowerShell alias. I think name string value. Description force new alias. Okay. Description will say new alias dash name list and get and a value. Okay, so we dash name and then dash value, a string, and create a read-only alias for command let. Create an alias for command with parameters. Okay, so our okay, local is the default. I output. What is the scope and how long will it? Parameters confirm. Description and all. Okay. So I go new alias. So I go new alias. I go dash name. I hope I'm doing it right. Yep, dash name, and the name is, let's say, np notepad, and then its value is notepad plus plus. So now I've successfully, I believe I've created an alias, right? So I go np, then source, headers, and texture.h, and source texture.c. Nice. Okay, so I can just to the left. Okay, so I'm going to add another function here, which is loads image into pixel buffer. Okay, so load pixels from file. So we go bold texture load pixels from file, and I think we don't have to create a texture, so I think I will have a surface. And what does it return? Okay, so I will have a surface. So instead of a STL texture, I will have to store a STL surface. And we name it surface pixels. Okay, surface pixels holds the pixel data. Hmm. Texture. Texture. So I would have to provide a texture, and what does it do? Surface pixels holds the surface holds the pixel data of the image, I suppose. Then we can just copy this, and yeah, okay. So what does this do? Loads image into pixel buffer. Okay, loads the image into pixel buffer. Then we have creates image from load from pixels. Creates image from preloaded pixels. Okay. Boom. Texture. Load from pixels. So I can go creates image. Okay. So I don't know what does it takes, but I'm pretty sure it will take the texture. So this creates an image from preloaded textures. Okay. Then we have free set color. I think I already have, right? Texture set color, text blend mode set alpha, and then render. Angle still point, center null, render flip. Okay. Yeah. Yeah. Still point center equals null. Hey, did my yeah, I also have a center. Okay. Right. Then we have this. Here we're adding new functionality to the texture class. We want to be able to manipulate a surface's pixels before turning it into a texture. So we separate functions, load pixels from a file to load pixels, and then load from pixels to turn the texture into pixels. We have a function to get the raw pixels and a function to get the pitch. The pitch is basically the width of the texture in memory. On some older and mobile hardware, there are limitations of what size of textures you can have. If you create a texture with a width of 100 pixels, it may get padded to 128 pixels wide. The next power of 2. Using the pitch, we know how the image is in memory. Okay. RGBA. Did I have a RGBA? No. Right, okay. So, pixel accessors. We get pixels 32, get pitch 32. Let's add these. See, let me just okay, so I have to also declare these three functions. Map RGBA, get pixel 32, get pitch 32. Okay, so we get khatam. Get pixels 32. I would have to provide the texture. Then we have get pitch 32. Pitch is basically the width of texture in memory. which is the width of texture in memory, how the image is in memory can be of different sizes, which we can determine how it is in memory. Okay. Returns the raw pixels of the image. Okay. Next we have a function, the map RGBA, which takes in a set of red, green, blue and alpha in 8 bits and gives us back a single 32-bit pixel in the format of a single internal STL surface. Okay. That is, sorry, map RGBA. RGBA. Okay, so we give it 8-bit RG, red, green, blue and alpha values. Which takes inside of red, green, blue and alpha and gives us back a single 32-bit pixels. Okay, this returns a single 32-bit pixel in the format of STL surface, in the format of आशी भाई अच्छी तरह से लगा दो, format of internal STL surface. Okay. In terms of data members, we have a pointer to the surface that holds our pixels. Okay. Holds the pixel data of the image. Right. Then we go on defining load pixels from file. Okay, maybe now that I have, right, I should use window, and wherever it asks a renderer, I should pass in a window. Right. Wherever it asks, so okay, window. So let's go into place. STL renderer with window. Next, replace, and that is all, right? Great. No more. Okay. So window texture. Okay, modulates alpha values. Okay. So we have load pixels from file. So let's see. Yeah. Replace, replace, and that is all. Okay, now the final texture, load the surface specified. Set the color key. Texture load. Loaded surface dash format. Okay. So still destroy texture. Right, so we have wherever it uses renderer, I want to replace it with window dash renderer. So I go replace, wait, okay, no, okay, nice, replace STL render, no, and next, no, copy X, yes, okay, so replace, where is it, yeah, replace, and next, window, okay, great. I would have to change the way it works, but that's okay. Okay, so this is creation, this is destruction load from file. Then I want to make load texture load pixels from file. Load pixels from file is use these okay, so let's get started. Pre-existing, okay, you want to free the pre-existing assets. Did I define a free? I don't think so. I defined a free. Maybe I think it means a texture destroy, right? Because there was no texture destroy here. Deallocates texture, so it means texture destroy. So let's go. Free pre-existing assets. Okay, so free pre-existing, so texture destroy texture. Then we move on to load image at specified path. Load image at specified path. So still surface, loaded surface, equals STL image is the STL image. Yep. Okay. So we load the image at specified path. So image underscore load. We have the file path, right? And I can check loaded surface should not be equal to null. Error, fail to load the image file. Then so we convert the surface pixels, convert surface format. Okay, convert the surface to display format. Okay, now convert the surface to display format. Okay, so we have texture dash. How can I just go pixels, right? Surface pixels, just go pixels. Come on. Pixels equals STL convert surface format. And then we have pass in the loaded surface. Then we pass in STL get window pixel format, and we pass in the window and a 0. Okay, so let's convert surface format. Let's take a look at this function. Convert surface format. Okay, copy an existing surface to a new surface of the specified format enum. Okay, so it returns the existing STL surface structure to convert. Yeah, the STL pixel format enum. What is the pixel? Okay, pixel type, pixel order, macros. That's a quite a big list. RGB A32, ARGB, PGRA. Okay. The pixel type is one of the following values. Okay, pixel type array 16. Depending on the pixel type, there are 3 different types of ordering: bitmap, backdoor, array. Bro, pixels are something complicated, I feel like. What does querying a texture give? Okay. Pointer filled in with the width of the textures in pixels. Well, if you don't need this information. Okay, a pointer filled in with actual access to the texture. One of the again, if you don't need this. Raw format of the texture. Pixel format may differ, but pixel transfer will use this format. This argument can be null if you don't need this information. Okay, but bro, this is get pixel format name. I can format and it will return a string with a name. Okay, so we will continue here. Then we check the pixel. Okay, yeah. Then we check that texture pixels should not be equal to null. There we go. Unable to convert loaded surface to display format. Okay, then we get image dimension and we get rid of the okay return, but we already checked this, right? Okay, so it returns true. Then we have get rid of the old get rid of old loaded texture. So error, fail to convert the loaded texture to display format. Oh yeah. I should provide STL error STL get error. Okay. Okay, then we go on to get the image dimensions. We get texture. I think there's a width and a height, right? Width, yeah. Texture width equals pixels width this corresponds to the height, and then we get rid of the old surface. Loaded surface so STL free surface loaded surface, and then we simply return true, and on error we return false. This function should look fairly familiar. It loads an initial surface in a way that's similar to the way we used to load from file minus the texture creation. Okay. Then bool L we have load from pixels. Okay, the only load if pixels exist. Okay. And then color key the image RGB color key the image. Okay, STL set color key. I need what does set color key? Yeah. What does this do? Set the color key transparent pixel in the surface. Okay. So we have flag STL to enable color key, to disable color key, and the transparent pixel. Okay, the pixel that it wants us to make transparent, right? Okay, so it color key. Loaded surface format. Use the surface. Loaded surface and loaded surface dash format. STL create render from surface. You use the renderer and the loaded surface. New texture. We check the texture height, loaded surface, and we see this. Okay, so I wish to use now texture load from pixels. So bool texture load from pixels, and let's see, load from pixels. Okay, so what else am I going to need? I need the texture itself, surface renderer. Okay, I do need a renderer. Create texture from surface renderer and surface pixels. Format STL map RGB. Okay, so it takes a format, and then it is like, and here's the other half of our old texture loading function that actually loads the texture, right? Pixels map RGBA. I think this should be here. Then destroy. Get, and we have set functions. Okay, so I do need a window here. Let's just copy this. Okay, so I have only load if pixels exist. Only load if pixels exist. Right. Check texture pixels should not be equal to null. Error. No pixels. Pixels to load from. STL error. STL get error. Okay. Error, no pixel loaded. Okay. Then we go color key the image. Color key the image. I get stl underscore set color key. Underscore set color key, and then it wants the pixels, and we tell it enable color key, and then we provide STL map RGB. STL RGB, within it we provide a format, comma equals 0, comma 255, comma 255, right? And then we close it. Then we create texture from surface pixel. Surface pixels. STL create surface, create texture from surface. Texture from surface. And then I have a renderer and surface pixels. So I pass in the renderer and the surface pixels. Okay. Then we check texture should not be equal to null, and we give an error saying fail to unable to create, yeah, fail to create texture from surface pixels. STL error, STL get error. Then we get the image dimensions. Height. Okay. Then we will get rid of old loaded pixels. Get rid of old loaded pixels. So STL free, I think, what is STL free surface is texture pixels, and then finally we return true, else we return false. And here's the other half of our old texture loading function that actually loads the texture. Okay. Then we want texture load from file. Okay. Load pixels. If not, fail to load pixels for this. Then else fail to load texture for pixels. Okay. Now here's the old load from file function refactored to use a separated loading functions. Okay. But what's the use, like here the ones is load media, load pixels from file, and we get that data. And color key pixels, every single pixel. I think that's a lot of work, Don't forget, whenever you allocate memory, always make sure to have a matching free. Right. This is a bit bizarre, Okay, I think I am going to cover till here, and then we will pick up next time. Until then, let me just save this session. Yeah. Okay, and P. Here we go. Session PC. Okay, and let's close it. And let's close it. And let's